Okay, let's solve question 6, page 203, November 2011. Figure 6.1 shows the position of layers of air at one moment as a sound wave of constant frequency passes through the air. Compressions are labeled C, rarefactions are labeled R. Here is a sound wave, a longitudinal sound wave, compressions C, rarefactions R. State how figure 6.1 would change if the sound had a higher frequency. So, girls, here they said state how this figure would change. They didn't say explain what will happen to the sound if, for example, frequency increases. No. So if you explain here and you say, for example, higher frequency, it means higher pitch, it's wrong. You will not get the mark of the question. You have to say what will happen to the figure. Okay. Let's understand together. Do you remember here when we represent the sound wave sometimes as crests and troughs? Okay, you remember this, right? We said this is air pressure. So, at each point here, what do we have? Compression. Each point here is a rarefaction. Okay. Now, if we have a higher frequency, what will happen here? What does it mean, higher frequency? It means more compressions and more rarefactions. So this one, it will become like this. So what I have at the same time or the same space, I have more compressions and more rarefactions. So if we have more compressions and rarefactions, what do you think? What will happen? The spaces here, and you will see that the compression and the rarefaction, they will become closer to each other. So what you can just say, so here in this figure, we will have more compressions and more rarefactions. This is what will happen to the figure. If they ask you to draw it, so easy. Just in the same space, bring the rarefaction closer to the compression. Shift, shift, shift. So you will put, instead of 1, 2, 3, 4, 5, 6 compressions, for example, you draw 8 compressions and 8 rarefactions, and so on. Clear? The second one, if the sound were louder, you know, louder, it means what? Because of amplitude. So here is it. If this one changes to with more amplitude, what does it mean? This is higher amplitude. This is a higher amplitude. So the number of compressions and their fractions will stay the same. The only thing will change is what? The pressure. Pressure will increase. Pressure increases, it means that the particles of the air in this area will become closer to each other. So when the particles, they become closer to each other, so the compression will stay in its place and the rarefaction will stay in its place. But what will happen? The particles will get closer to each other here in the high pressure, in the compression, and in the rarefaction, the pressure will decrease more and more. So the particles will go farther away more from each other. That's what will happen. Okay, so compressions get narrower. So this compression, instead of this this space, for example, you will see that the narrower the lines will get closer to each other, and the rarefaction, the line will get away from each other. Okay, I hope that everything is clear till now. On figure 6.1, draw a line marked with arrows at each end to show the wavelength of the sound. So where is this line? Here. I drew the line here from the center of this compression to the center of this compression. Okay? In an experiment to measure the speed of sound in steel,